Hello, everybody. I would like to do the question 76 in calculus section in this video. This is for the course Math1151 at University of New South Wales. The function we have, fx is equal to this notation, is for the floor function. Floor function is the greatest integer, which is smaller than or equal to x. And we would like to find out that for each integer, we would like to find out the limit, left limit, right limit, and we would like to conclude that if it's not continuous of every integer, but if it is not an integer, for example, if it is a 1/2, we have the continuity for each rational numbers. And then eventually, we would like to use delta epsilon definition to show that the limit x goes to the 1, f of x does not exist. Okay, first, let's try to understand what this function is all about. This function, the greatest integer smaller than or equal to x, can be written mathematically in this way, right? Maximum of all integers such that integers are smaller than or equal to x. Let's do the graphing first. For each n is equal to z, for each integer, then the function will give it the integer because we have an equality sign here. So for each integer, the outcome of this function is n itself. But for example, if we have -2, f -2 is -2, f -1 will be, f -1 will be -1, f0 is equal to 0, f1 is equal to 1, f2 is equal to 2. So this is the f2 is equal to 2, f1 is equal to 1, and so on. But if, as you realize, if we have any rational number between here and here, with, for example, -2 to the 2, then the outcome of this, any rational number in here, will be -2. So this is the -2 goes up to the point -1. But in -1, the function outcome will be -1. And then we have any rational number bigger than -1, smaller than 0, bigger than -1, smaller than 0. This is x. F -1 is -1. Any rational number, the f value will be just -1 because that is the integer smaller than or equal to that rational number. For example, f0 is equal to 0, f1/2 is any rational number in here, then the outcome of this function will be just 0. 0 means as the x-axis, and so on. So we have a staircase function. Define it in that way. So once we understand the function, it will be easier to solve the problem. So what we want to find out that f is not, first question is that f is a left limit and right limit, and they are not equal. That's what we would like to figure out first by just using the limit, usual limit definition. Okay, this is exactly by using the definition. If we have for every x between n-1 and n, the smallest integer will be n-1, and the outcome of this function will be n-1. So a limit x goes to the n from the negative side, any number in between that will be fx, will be n-1. That is different from n, because fn is always n. It means that is showing that this continues. We particularly say this one is a left discontinuous, discontinuous, because this x goes to the n from the left-hand side. From the right-hand side, it is right continuous, because if we have for all x's n between n and n+1, then the outcome will be n. right? The outcome will be n. From the right-hand side, when we are approaching to the limit from the right-hand side, the output will be n, and that is exactly fn. So this here means that the right limit exists, and it is equal to the function value at that point. It means it is right continuous. But don't worry about the left continuous and not right continuous in that moment. I just give an extra information here. The key idea is this limit and this limit is not equal to each other. It means that f cannot be continuous. So f is continuous because this limit is different from this limit. Okay, so that was the first part. Now, in the second part, we would like to use delta epsilon definition and find out that this limit is f is 1 over 2. That is, that f is continuous at 1 over 2. This is what we are going to show. First, we observe that the f 1 over 2 is the outcome of this function will be 0, because the 0 is the smallest integer, largest integer smaller than 1 over 2. Right? Largest integer smaller than 1 over 2. That's what it is. So it is 0. For each epsilon, our aim, because we would like to find out for each epsilon, is there a delta such that for each x, this inequality implies this inequality. So this is just a definition. This is delta epsilon definition, as we know. Here, this inequality is basically taking out the absolute value. We have the minus delta here and plus delta here, so it will give us this inequality. So by taking the minus 1 over 2 to this side, we will have minus delta plus 1 over 2 smaller than x and smaller than delta 1 over 2. So the x between a small neighborhood of 1 over 2. This is what it is. So this inequality means the function outcome, which is that function, is between minus epsilon and plus epsilon. The function outcome is in the neighborhood of epsilon, and the x is in the neighborhood of delta 1 plus 2. So you're thinking about a rectangular band and whatever it's happening here. Our aim is to find out the delta. We can find out, try to find out a general delta, but it's enough to find out one delta satisfying this condition. So to make our life easier, let's say delta is 1 over 4, and let's see if the condition satisfies. If the delta is 1 over 4, then 1 over 4, I'm putting the delta 1 over 4 here, and then here I will have 1 over 4 by addition with these two. And then with the addition of 1 over 4 plus 1 over 2 will give it be 3 over 4. So x, while x in this interval, this implies that fx is equal to 0, which is true. And the 0, and since epsilon is any real number bigger than 0, that satisfies already. Because this assumption for each epsilon bigger than 0 means is implied here directly. So it is all done. This means that limit x goes to 1 over 2, f of x is equal to 0, which is equal to f1 over 2. The function value f1 over 2 is 0, and when it goes to the limit is also 0, because we found delta satisfying this condition such that this inequality implies this inequality. This is what we proved here. This inequality implied this inequality. That is exactly what we wanted. This is the delta epsilon definition for it. We prove that the limit x goes to 1 over 2, f of x is equal to 0. The proving of this equality is exactly the finding out the delta which this equality implies this inequality, which was exactly, so this needs to be maybe, this is what is the key idea in this question. I hope it is clear. If it is not clear, please try to do it by yourself, by thinking to yourself. It is not easy to explain because you need to think about it in order to be able to understand it. Let's have a look at the last part of this question. This, we would like to use delta epsilon definition, and we would like to prove that limit x goes to the 1, fx does not exist. Observe that if x between 0 and 1, limit, so this one I'm doing it as a usual limit and try to see what is happening in a corner, right? This green part is for me to understand it. I haven't started to solving this problem yet. I want to know what kind of things that I need to focus on, what kind of things that I need to solve. This is why I am performing this calculation here. So if x between 0 and 1, limit x goes to the 1, it means that you're approaching from the left, the function outcome will be 0. Right? The function is the greatest integer smaller than or equal to that number. If x between 0 and 1, the smallest integer is 0. If x is between 1 and 2, so you're approaching from the right-hand side to the function, and the function outcome in this case will be 1. 1 is the greatest integer, greatest integer smaller than x, which is 1. So this is 0, this is 1, they are different, so limit does not exist. Now we would like to do this by using the epsilon delta definition. Epsilon delta definition means that for each epsilon, we would like to find out delta such that for each x, this inequality implies this inequality. So our aim is to find such delta. From this inequality, just opening up the absolute value, that will be minus delta plus delta here. And then you have minus 1 here, adding 1 in each side. We will have minus delta plus 1, and we will have delta plus 1. As we've done in previously here, when we are trying to understand what we are doing, we need to look at approaching from the left-hand side and approaching from the right-hand side. So this interval contains 1. So we need to think about the n interval up to here, up to 1, another interval from 1 to here, which represents the left approaching to 1 or right approaching to 1. So this is why we need to divide two cases, to the left and right. For x's in this interval, the outcome will be 0. Because minus delta is a very small number, right? So you have 1 and you have a very small number than 1. Then the outcome of this function has to be 0 because that is a rational number. Between any x will be a rational number between these ones because delta is a very small number. Minus delta plus 1, so this is something very small than 1. Then that rational number, the greatest integer smaller than that rational number will be 0. And clearly, since epsilon, we are choosing epsilon for bigger than 0, that 0 is already in the assumption. It is always true. if x between 1 and delta plus 1, again, think that the delta is a small number, and 1 plus delta, so x being in this interval means that x is a rational number, is a little bit bigger than 1. This is what it means. Then f of x, the outcome of this function, the greatest integer smaller than that, 1 point something something, then the greatest integer smaller than that rational number will be 1. So this is why we have 1 here. This equality means fx minus 1 is smaller than epsilon. Then this is true for each epsilon. This is always true. So what we found, zeros, this interval, 0 from x minus 1 to delta, does not imply that fx minus L is smaller than epsilon. It is true that exists, we have 1 here, and here we have 0, but we don't have certain L satisfying both at the same time. It is the same idea here. We do have some kind of L here, L is equal to 0 here, L is equal to 1 here, but these are different numbers. They are not the same. This is what I'm trying to say here. Yes, we have L is equal to 1 here, L is equal to 0 here, but L should be the same number. So we don't have such L. This inequality does not really imply this inequality for some L, for one some L. So there is no such L. That means that the limit does not exist. So this logic is exactly the same thing. The left limit and the right limit is different and does not exist. This looks a little bit complicated question to go through. I understand it might be hard to understand. It is hard to grasp it in the first time. So please take your time and sit and do it and think about it. It will be much more clear if you're doing it by yourself. Thank you very much for listening.